Good afternoon. Welcome to the October 19, 2025 O-Scale Central Online program. I'm David Vaughn. Repeat viewers on this monthly program have already heard the introduction I'm going to give, but as we get new viewers every program, both live and rebroadcast on YouTube, I'm going to give the introduction so the program stands on its own feet. This program is about O-Scale 2-rail, a model railroad scale of 1/4 inch to the foot, 1:48 proportions. It runs on 2-rail track, just like prototype trains. O-Scale 2-rail is almost 8 times the mass of HO. The scale has detail you can see, mass you can feel, and satisfying models you can build. Although nominally the same scale as Lionel, O-Scale 2-rail trains are built to prototype proportions and operate in a prototype manner. O-Scale Central, which sponsors this program, is a nonprofit 501c3 tax-exempt membership corporation whose mission is to promote O-Scale 2-rail and support modelers in the scale. We are NMRA's Special Interest Group, or SIG, for O-Scale. O-Scale Central has information-filled website at oscalecentral.com. We publish a quarterly journal and a monthly newsletter filled with interesting features about O-Scale 2-rail products, modelers, layouts, clinics, and news. O-Scale Central maintains an active outreach program to train shows, RPM meets, and NMRA conventions. We also sponsor this monthly online program using the Zoom platform. We bring in top manufacturers, importers, and newsmakers in the scale, present layout tours of quality O-Scale 2-rail layouts, short clinics, and news you can use. If you miss any program or know someone who should see it, the program is recorded and is available on YouTube, either directly or through our YouTube channel. Get that through the O-Scale Central website, oscalecentral.com. O-Scale 2-rail is a scale small in number of active modelers. Because of our small size, the scale operates largely below the radar without the level of manufacturing support, advertising, and visibility enjoyed by other scales. But the O-Scale community is tight-knit. We are supportive of each other and of new O-Scale modelers. O-Scale Central and other organizations keep us on the move. We provide this program, as well as our website, as a service to the scale. As indicated, you need not be a member of O-Scale Central to use the website or to view this program. We think keeping the O-Scale 2-rail community informed and cohesive is important. That said, we hope you'll see the benefit of what we do, enjoy the program, and join O-Scale Central. Your dues money makes this program and our other activities possible. So go to the website, find the membership section, and follow the prompts. Basic dues are only $24 a year. At the present rate of inflation, that's about one Starbucks. We have a terrific program today. Let me tell you about it. O-Scale 2-rail has been held back by our small size, which limits new projects. Traditional tooling is expensive. Tooling costs must be amortized over the production run. Required minimum orders are generally larger than our small market allows, and carrying inventory complicates logistics and ties up capital. What if there was a way to eliminate tooling costs, eliminate minimum orders, and require no inventory? And the answer is there is. If you design models in CAD and print them in 3D. CAD is an acronym for computer-aided design. 3D printing allows a CAD-designed project to be printed as a three-dimensional object. Any object, like that favorite part of your favorite railroad that nobody is ever going to make commercially, or a piece of rolling stock. In the background over my left shoulder is a model of a John Armstrong designed 200-ton articulated covered hopper, which he called the Cementipede. It offered by my company. The Cementipede is all 3D printed, the whole model. So the process to eliminate tooling, minimum orders, and inventory is already here. It's revolutionizing many aspects of manufacturing and will revolutionize model railroading. No part of model railroading will be impacted more and more positively than O-scale 2 rail. But the vocabulary and the processes are foreign to model railroaders who use conventional modeling techniques. And if you aren't a techie or have full-time access to a bright 12-year-old, it's easy to be put off or get lost. The first segment of our program today is a primer on how to understand and navigate this important emerging part of the hobby, and importantly, make it work for you without having to become a full-blown techie. Daniel Rabel, our presenter, is a PhD aerospace engineer who works for NASA. Please wish him well on getting back to work from his current unpaid status resulting from the government shutdown. Daniel is also an enthusiastic O-scaler. He's not only a gifted creator using CAD and 3D printing, but he has the ability to speak tech in a way lay people understand and how to make it work for you. 3D printing is a popular topic for clinics. Daniel has a presentation that is head and shoulders above most clinics that I've seen and is eager for your questions. Our second presentation today will bring front and center another emerging trend in the hobby, modular model railroading. For all of our workarounds, O-scale is still a space gobbler. By assembling small modules, large O-scale layouts can be created and operated. Modular layouts are great for younger, newer modelers whose space and budget limitations and mobility needs limit a permanent layout. But it also works for retirees who downsize their homes and layouts, or for modelers in the middle of their modeling career who want more group interactions. Modular layouts require standards. The pieces have to fit together, so track has to mate, and construction methods have to be consistent. And modular layouts work, building skills, promoting the hobby, and having fun when there is a successful group to build and operate them. My good friend and O-scale Central Vice President Nick Bulgarino will lay out the world of O-scale modular railroading, from the standards to building a successful group to construct and operate the layout, to have fun and build friendships. We have other news and announcements, and we will make room for them. But before we turn to the program segments, I want to introduce our treasurer, Joe Norman, to tell us briefly about the contributions of his friend and mine, George Wallace, and to make the presentation of the first George Wallace Service Award. And with that, Joe, you're on.
Okay. Many of you probably knew George. George was a lifetime O-scaler, and George is responsible, amongst other things, for keeping O-scale Central alive for many years, where there was a drought in enthusiasm, I guess is the best way to put it. George also kept alive the Southwest O-scale meet, which we just concluded yesterday. Had about 50 people come in from Texas, had some from Kansas, a couple people came from California, and everybody had a wonderful time. As part of that meet, we awarded the first annual George Wallace Lifetime Service Award, and we presented that award to John Smith, another person who I'm sure most of you at least have heard the name. John is another lifetime O-scaler. He started, as working in Bobby Hall's hobby shop down in Dallas, but he decided he wanted to go into business for himself, and he started his own store in his garage and was reasonably successful, and moved into a building in Louisville. He went on to found the Pecos River Brass importer company. Primarily, John was interested in the Santa Fe Railroad, and his first imports were a couple tank cars of Santa Fe design. John, unfortunately, is not doing well these days. He's in a nursing home, and the award was presented to his very close friend, former employee, helpmeet, etc., Phil Camp. And Phil and John's wife, they're going to present it to him this week coming up. John's currently confined to a nursing home, and he's unable to get around very much anymore. So, as I said, we're going to make this an annual award. So, and I guess I've been by default elected the coordinator of that effort. So anybody who would like to make a nomination for a person who they feel is deserving of the award, please send your name, his name, and some brief background material to me. And the award is going to be made by the board. Not all I'm going to do is give them the information, and they go from there. So just send it to me. My email address, OSC Treasurer, and we'll be doing this again next year. And if I might be permitted one shameless plug, we're also going to be doing the Southwest O-Scale meet again next year. And so I invite everybody to come in. We'll be sending out information on it. Probably it'll be first of the year or later, give you time to plan, but it will be held in the same approximate time, about midway through the month of October. So thank you.
Thank you, Joe. I really appreciate it. I would note that George Wallace was an Air Force pilot and flew some ungodly number of combat missions in Vietnam on
about 100.
That's a boat when they're shooting at you.
Yes.
So he was a tremendous guy outside of our predecessor organization, O-Scale Kings, but he was really the glue that held it together during some very dark times for the organization before we were able to pull it together and go on a rebuilding revitalization campaign. And we all owe a debt to George and to John Smith, who not only was an importer of some fame, but was also the founder of O-Scale Kings. I think you probably said that, but in any event, he was a major influence on the scale. And thank you, Joe, for that that presentation. I think it's most appropriate that we honor both George Wallace and John Smith. Thank you. All right. We will be flagging news. There are some coming events that are certainly worth highlighting, but I want to just flag, partly because of the content of our program today, that in 2 weeks, on the 1st and 2nd of November, is the O-Scale show in Cleveland, which includes as its second day a modular meet. And all of those events, including the Southern O-Scalers and the March meet and Strasbourg and anyone else who is holding meets, are available in the directory of coming events on the O-Scale Central website. All right, what I would like to do then is turn to Daniel Rabel, who has already been introduced, and have Daniel walk us through O-scale CAD design and 3D printing and how to make it work for you. Really appreciate you appearing, Daniel. Thank you very much.
Well, thank you very much for the opportunity. Let me get set up here. Okay, is everyone seeing that okay?
Yep.
Great. All right. Well, thank you again for the opportunity. It's a real honor. At the tail end of this, if some of you who might have joined later might not be able to see it in the chat, so I'll repost it at the end, a PDF version of this, because there's a lot of links in there that you might want to go back in and review when all is said and done. But again, I'm Daniel Rabel. I'm from the greater Cleveland area, which you're seeing right here, the beautiful Terminal Tower, which had a lot of interesting rail traffic in and out before my time, and that's certainly one of my interests. So this presentation, I have several goals. I kind of consider it a primer on 3D printing, maybe an introduction to help get people comfortable with it and hopefully using it in your workflow so that you can complete some projects. And I'll start with just saying all the files that I make for everything that you're going to see in this presentation, these catenary towers included from the Cleveland Union Terminal, are free for download. Either you can click on that link from the PDF that I have there, or just take a picture of those QR codes that you see on your screen right now, and it'll take you directly over to my repository of files. And I'll say that again here at the end. But here's my goals for this presentation, to have you gain some familiarity with the different components of the 3D design and printing process. And hopefully in the process of that, you'll get kind of inspired here to help contribute to a portion, of that in the future, learn some gotchas along the way, but also see some of the awesome things that only can be done through 3D printing, and build your confidence to help get involved with this. And the main takeaway from the presentation is you don't have to become a 3D guru, nor should you, in order to benefit from the results of that. There's a lot of little elements of it, more than what one person can handle. And in fact, many of you on the call are already contributing greatly to this, and hopefully it's paying you back by, as David said, very nicely, generating the favorite part for your favorite railroad that no one else is going to do, which is the story of my life, it seems. So, little background on me. Again, I'm from the greater Cleveland area. I enjoy woodworking very much, more than anything, whether it be for RC aircraft or model building for railroading. So I love scratch building. But every once in a while, there's something that can't be done in wood or styrene, and that's what really drove me into the 3D printed arena. So I'm very fond of things that have been gone at least 50 years before I was even born. I love traction modeling, especially pre-World War II and even pre-Depression era. My favorite thing to build is those old wooden label kits. I like the Lakeshore Electric very much, and I was in search for trolley fenders for the Lakeshore Electric. I've soldered them from scratch, and that's very challenging. So that was my first project, as you see in the upper left-hand corner, in 3D design, which was, could I make one of these things out of resin and print them out? And the answer is yes. You can see the prototype there, and it being mated to a Lakeshore Electric box motor in process. And shared that with some local traction friends that I have here, and they were working on a layout for a gentleman, Joe Laskowski, who was putting in some overhead near Route 8, and he wanted the catenary towers from the Northern Ohio Traction and Light. And so they came to me and said, "Hey, could you make these towers since you made that pilot?" And I said, "No, but I'll try." And so they sent me some pictures that you see here, and I was able to produce them, and Jim Rivers from River City Traction did the overhead catenary wire, and there's one of the inaugural runs. You can see a little Pittman freight motor navigating a portion of what would have been the Northern Ohio traction and light using those towers. So that was a good confidence builder for me, and just great to be able to contribute to someone's layout, something that works, something operational. So now I had two kind of things under my belt. And so from there began what led me to today. I hear this on a daily basis. Well, if you can do that, can you do something else? And there's a gentleman who scratch builds nickel plate depots and maintenance away structures up in Vermilion, Ohio, and he was working on some of the nickel plate structures that had some challenging aspects to them, like the octagonal bump out at Kimball, Ohio station, and then some of the more ornate gingerbread-esque architectural elements. So I started, that's Bob Kaywood up in Vermilion, and he generates things in O scale and HO. So I started making windows and the ornate cornices and some of the siding that you can see in the lower left-hand corner, just things that would be added to a scratch-built structure to make it pop. Certainly some of this could be scratch built, but now we're starting to get into some things where it's hitting the limits of what you would want to do, on the bench with carving and styrene in that. So I felt pretty good about this marriage of blending some of the old techniques with some of the new techniques, and it helped Bob out a lot. So that made me pretty happy as well. So beyond there, then I kind of swung for the fences, and I wanted to attack the Cleveland Union Terminal approach, the Cuyahoga River approach, which you can see a portion of here. So here's where I want to talk about research, because I think this is where this is no different than any other model railroading. Where do you get the information if you want to build something, from scratch? This is an enormous approach. It's about a mile long. You'd have to hop a barbed wire fence to take measurements of it. So that is doable once in your life and then never again. So out of a book, here's a wonderful picture taken by Dave McKay from one of his railroading books. It's head on. And from here, what I did is I took the JPEG of this picture, put it into my computer, scanned my model railroad reference ruler, and from that, I can slide it around and take dimensions from the photograph and try to figure out basic things like, well, how far apart are these, railing posts? So I can generate, a railing from that. And so a lot of information can be extracted from photographs like this when you don't have the proper plans to generate things like the height of catenary towers and the spacing, between railing posts. So same thing as you would have to do, from a scratch building perspective. Fortunately, in Cleveland, if you park at Tower City, which is the current name for the terminal tower, and the parking deck where all the approach tracks were, you can physically park right next to one of these towers. And each tower is a little different, but I was able to get from the measurements just with one of those, cheap magnetic inclinometers and a tape measure, get all the measurements for the tower, and that helped greatly. So a combination of pictures from books, pictures that I took, but the best was working with the actual prototype, which isn't always possible, but in this case it was. We can try to attack this project one piece at a time, as Johnny Cash would say. So it's always the best when you can actually interact with the prototype. For some other elements, like I mentioned, not all the towers are exactly alike. The ones that go across the approach have some extra elements on board. Notably, they carry electrical wires, so you can see that extension over the top. There's a transformer platform. So I would just kind of ride the train back and forth. This is during a Browns game, so no one was on the train, but you can see the Goodyear blimp overhead. Downtown was pretty desolate. And I got a lot of nice pictures, and, because I know some of the measurements, from that, I can extrapolate other measurements. So again, using pictures, same way that if we were a scratch building here, not unique to 3D design, but, banking on, advice from others and how to get all of this information, how to basically get information we need from information that we know. Another project that I did recently west of Cleveland is Lorain, Ohio. That's the Black River. Just west of the river was a freight station, which no longer exists, and the platform's gone as well, but The crane, the freight unloading crane, is still there. This used to be a manual crane, about 100 years old, more than that actually, that was electrified at the turn of the last century. And so I was fortunate to be able to just scramble around that thing on a Saturday morning and generate the 3D design for it. And you can see a little prototype that I made where you can make it operate as well. These are called pillar cranes, and very popular along the main line. Not a whole lot of them still exist, but when this stuff is there, you got to get out now and get them captured before Father Time reclaims them. In Southwest Ohio, there are still some of the original US and S signals not being used. You can see they're turned 45 degrees away from the main line here. This is on the current RJ Corman line. But I was able to get out and capture the single mast and the dual mast variations, and you can see my drawing in the center, and then some of the early 3D prints of those color light signals, and I did the battery wells as well. So again, all those files are online, and you can have a very accurate O-scale representation of the US and S signals now. I had some requests from some DT&I fans up in Michigan. They wanted the emblem, which you can see in the top right. This was on the tender of their steamers, just a beautiful cast emblem that would have been bolted to the side of the tender. And a gentleman had one in his house. He measured it all out, sent me some pictures, and I was able to make kind of what looks like a little coin with a very thin backer that you can affix to the side of a tender and then paint to help model DT&I properly. And then, of course, when I think of the DT&I think of Henry Ford and the short-term electrification of it, and those very interesting Art Deco concrete catenary structures. So I generated that design as well, and they still exist today. But I was able to get that just off of Google Earth, in fact, and going overhead with the tape measure and taking measurements between them and side to side, scaling the pictures like you see in the lower right-hand corner to generate the proper CAD model and then print them out, which you see in the center here. Okay, mechanical prints are very useful, although they're not the be-all end-all. Sometimes it's very hard with a complex element like these AAR-A trucks to discern really what's going on. So it's great to have a mechanical print, but pictures and like I said earlier, interacting with the prototype is always the best. So from the prints, I was able to generate really nice AAR side frames, and those will snap onto Atlas switchers and other things as well. But instrumental in this was getting out to the museum. In fact, Greg Vigiano, I met him over at the Baltimore and Ohio Museum when I was on a work at DC, and that was great. They gave us keys to one of their SWs to check out, and we got a lot of nice pictures. And it was nice to fill in some of the details that aren't necessarily revealed, in the prints. But prints are great when they're available. And same thing on the right-hand side. Using the prints, I was able to generate some of the signal and power utility poles in O-scale as well. Several different variations of that. This one was more challenging, and this is a work in progress. This is the engine house, which still exists in Frankfurt, the roundhouse, and the turntable there at the Frankfurt Nickel Plate Yard, now Norfolk Southern. And I've never been there, and yet people, some of whom I've never met, but hopefully will someday, have been emailing me all kinds of information, from hand-drawn sketches to pictures they've taken, or just sharing anecdotal stories of the work that got done there, which helped me put together the puzzle of how to construct each of the elements to build a roundhouse from the ground up. And you can see some of the interior structure there. I've mostly got the interior done as far as all the beams, post beams and trusses, and I'm just getting started on the external brickwork. The first thing I did, here's Jim Cantor in the lower right-hand corner. He sent me a picture of him sitting on the flagpole base. That was the first thing I did. I made the flagpole base for that, and then at the top right, the vehicle clearance sign that the trucks would have driven underneath to enter the roundhouse. That's gone, unfortunately, but it can live on in O-scale at least. Okay, so let's actually talk about the 3D part of this. I use as a tool a program called Fusion 360, which is made by a company called Autodesk. They were the originators of a 2D program called AutoCAD. And so the 3D version of AutoCAD is called Fusion. I'm not going to tell you it's the best program out there. It's just the one that I use, but there are all kinds of very good programs out there that you could use. People who actually know what they're doing with this, the mechanical engineers, they are very fond of a program called SolidWorks. So if you're more mechanically inclined, that would generally be your weapon of choice. I got started with a free program called Google SketchUp. And that was great and still is very good, especially for simpler objects. Uh, David's comment about the 12-year-olds is also on point. 3D modeling is a great way to interact with younger folks and get them going with the hobby. And there's a program called Tinkercad, which is excellent. It's really targeted towards youths to help them get started with 3D modeling. It is definitely more limited than something like SolidWorks, but a perfect first project, for a niece or a nephew or a grandson or a granddaughter would be to select something like a bridge abutment or something fairly straightforward that you could maybe go out for a day, go on a field trip, measure out, or get the plans from a book and have them, measure something out and build it in Tinkercad, and then either have someone else print it for you or print it yourself if you have a 3D printer, which we'll talk about here in a couple slides. But there's all kinds of different levels of entry where you can get into the design process. Now, that said, you don't have to become a designer to become involved in 3D, but if you want to, these would be several of your options for actually performing the 3D modeling of the design. So let's look into what that actually looks like. I'll give you a snapshot of, what happens in the box in the computer when you're drawing up these designs. So let's take the AARA truck example here. Let's say I want to develop this side frame for a diesel switcher, maybe an NW2 project, which we're working on. The first thing that you do is no different than any other drafting program. Nothing new here for the last 150 years, just good old 2D drafting, standards. The only thing that's changed in drafting in 150 years is we now do it with a mouse instead of rolling, a pencil on parchment, right? But other than that, the techniques are the same. So we draw a 2D representation of our three-dimensional object from one perspective. And so here you can see in the top left-hand corner, step one, I'm drawing half of the side frame of the truck from the side view and putting in not all the details, but the predominant details that define that side frame. Here's where we get into 3D world. So once I have a 2D representation of that object, I am now going to extrude it, just like a manufacturing process of extruding a beam, from an extrusion machine. We are now going to grab one of the elements of that 2D drawing and we're going to extrude a body out of the drawing. So now we have a three-dimensional object, and that's what you see in the lower left-hand corner here in the green. So now we're in the 3D realm. And then we are going to repeat what we did in step one. We're going to go back into the 2D realm and we're going to generate another two-dimensional drawing, except now we're going to generate it from a different perspective. So here I chose to start with the top of the truck as if I was looking straight down on that side frame. And I'm going to draw kind of everything that I see there from a top shot. And when I'm done with that perspective, I then am going to extrude that through my previous three-dimensional body, which is going to remove the majority of the material. And the result of that you'll see in the top right-hand corner. So now I have two extrusions that were 90 degrees apart, extruded across each other. And now I have a very, blocky, Minecraft video game version of what an AAR truck would look like, but it's starting to take form. Hopefully, you can kind of see that if you squint. Yeah, that looks like a quarter of an AAR-A truck. And that's the entire process, because from then on, We just keep doing that over and over and over again, but zeroing in on little details and starting to add things like chamfers and fillets to round things over. But just getting in there on the little details and adding them kind of one at a time. And so it's just iterating, step one, step two, and step three over and over again until finally we have the full truck rendered and we save it as a three-dimensional file. Hopefully we save that about 1,000 times so we don't lose our work when our computer crashes during the process. But that's a 10,000 foot, view of what happens when we're creating these 3D models. So there's a lot of kind of problem solving that goes along in this. And so here's some things that I'm thinking about when I'm in the middle of putting one of these designs together. We're not actually being engineers here, right? We're not making, let's say, this dwarf signal right here. See that there's a latch on the rear where you could go in and service the bulbs or the electrical system. We don't want that latch to open. If this was an actual drawing, I would make sure there was some clearance between, the prong, and the actual hasp that's closing on it. But this is a model and it's never going to open. And so everything really for me, you want it to look correct, but not function correctly. So there won't be clearance between a lot of the elements. Another way to say that is everything should kind of melt into each other so that when it prints, you have one solid object that's very strong. And then once you paint it and weather it, it's an approximation of the real thing. But of course, it will be a lot stronger because it's going to get knocked into and handled. And, you don't want operational hinges on something like your dwarf signal. So when you really look closely, at these designs, you notice that it's all kind of melted together as one single piece, even though it was put together by a bunch of individual pieces. There isn't clearance between things. Probably the best way I can illustrate that, show that to you, is on the right-hand side. This is way zoomed in of the interior truss structure of one of those catenary overhead supports. The outside looks great, but you can see the inside is very chaotic. All those angles are coming together. Everything's overlapping. You would never build anything mechanically like that. But we want that in the model because we want that to be strong in the end so that we're holding it in our hand. We don't, the hand of God doesn't crush the catenary structure. So some things that we think about, while we're designing. So let's look at that a little bit more detail. Let's go run through it one more time. We'll go a little faster now through the design process. So on the left-hand side, you can see that I drew a rectangle at the top, just a two-dimensional rectangle, and then I extruded it downward. So now I've got, a piece of plate steel, if you were, right? And then from that piece of plate steel, I might draw another rectangle behind it, and I might extrude it down at an angle because I want an angular brace. So now I've got two 3D objects which are touching each other. And maybe I know the thickness of that plate steel. Maybe it's 1/2 inch in real life. Well, if I'm making an O-scale model, might bump that up to 3/4 of an inch or maybe even a full inch because we want this to be strong. This is going to be plastic, resin at the end in O-scale, so we need things to be maybe a bit thicker. And then we'll add some fasteners to it. We'll add a round fastener and a hexagonal fastener. So we have like a hot rivet and a bolt. So I'll draw both. Again, to make a decision here, if it was a 1/2 inch bolt, maybe we would make it a 5/8 inch bolt. Or if it's a 3/4 inch bolt, maybe a 7/8 inch bolt. Not necessarily, but for clarity, we might want to enhance some of the fasteners so that when it's reduced down to O scale, things are still going to be nice and visual, at that point. So we drew a circle, we drew a hexagon, and then extruded those back and away. And then we'll add some detail to them. We definitely want to have shafts for them. So then we'll draw 2 circles and extrude one shaft back and the other shaft coming out to represent, the threaded rod or the bolt shaft. And then we can add some chamfering to the hot rivet, and we can add a spiral to make the threads and a little chamfer on the end, for the actual bolt. And this is looking pretty good, I hope. It looks pretty good to me. And then the last step is I can draw a dotted line across and I can reflect the entire thing that I just did across that dotted line. And now I've got a piece of angle iron, and it's really looking like a piece of a truss structure. And this whole process took me longer to just describe to you than to actually draw. This kind of stuff can go very, very fast. Now, we could stop here and send this to the printer and print exactly what we see. But thinking about strength again, we could go one step further as Mother Nature and Da Vinci taught us. There's strength in triangles. So if we were only going to see the outside of this design, one thing that I might choose to do is go around to the inside and add a large fillet so that it'll fill up that angle iron, and now it's really going to be strong. And this is something that I won't do all the time, but again, if you're never going to see the inside, then you'll never know. Might as well add a concave fillet or just a triangular fillet, just the same. We can apply this the same way on the signals. The weakest part of a signal is going to be the hood over the lens. And to make that hood appear like the thin sheet steel that it is, one technique that I've done is taper it down to the sheet steel thickness just at the lip of the hood, but make it wider at the base. That way, again, when you're handling it and painting it and weathering it and installing it or accidentally knocking into it with your hand, you don't knock the hood of the signal clear across the room. So this is kind of Walt Disney-esque in a way, right? We want to make things appear correct, even though they might not be accurately, dimensionally correct to the model, which is all part of modeling. Along those lines, let's look at rivets. How large is a hot rivet? There's many different standard sizes on that, but think about that for a sec. We're O-scale modelers, but you're aware of the other scales. And when you pick up an N-scale steam locomotive and you can see the rivets on it, you should expect that those rivets are a lot larger than N-scale rivets, because if they weren't, you'd never see them. And the same applies for HO and to a lesser degree O-scale. So it may make sense to make fasteners just maybe for O-scale, I think maybe one size bigger than what the original size is, and that'll help it scale down to 1/48 a little better. As you can see in the Hewlett-Oron loader here, that's one of the techniques I did with that design. But let's think one step more, right? Because when we're modeling, we're going to make a 1/48 scale version of it, but then we're going to use real paint in the real world. We're going to cover our model in primer. We're going to cover it in paint. If it's a diesel or a steamer, we might clear coat it because we're going to do some decaling. Then we put the decals on. Then we're going to seal the decals with some more clear coating. Then we're going to apply weathering. So whatever rivets we had on the model are just being covered over physically more and more from all those layers of paint and weathering. So for that reason, again, going back to the 3D modeling part of it, some early decisions need to be made. And how big do you want those bolts and those rivets to be? So when you see a raw 3D model, a lot of times, and like you're seeing right here, the rivets and the bolts are a little overemphasized so that later, after all the finishing steps, they will appear at the right dimensional sizes in the prototype. In general, I like to not use my brain when I'm doing this stuff because I'm very prone to make mistakes. So I design in full scale. That way I'm not sitting there with a calculator dividing by, 48 or, multiplying by 0.0203 or 0.2083 repeated after that. So I'll design in full scale. That's relatable to me. And then at the end, I'll scale the model down, to O scale, 1/48 scale, as you see here. But in the process of doing that, some of this detail is going to be lost. In O scale, you can read in these builder's plates, you can read the superheater company, for example, but those patent numbers start to fall away at O scale. If you jump down to 1/87th scale, you definitely won't be able to read anything on the Alesco sign, and barely the Wheeling and Lake Erie on the builder's plate there. So just some things to keep in mind. Not everything translates depending upon how small, we're going down there. And, if something works really well in O scale and then an HO modeler wants it, you might have the problem of structural integrity. A good example is those catenary structures that I made, which look perfect in O scale. I can't make those in HO because they're too weak. So you have to basically go back to the drawing board and thicken everything up, which is on my to-do list, but fairly far down on it because I'm an O scaler. I've got other work to do. Okay, so let's go to the next chapter here. We need to print the parts. Either yourself or your friend generated the parts for you, or maybe you bought a design. There's all kinds of places where you can find, 3D designs. If you know Sarah, Train Kitchen, she has a whole website where you can download designs right there from her. And either way, you have a file, and it is a .stl file, which means stereolithography. That's the 3D printing technology that we're going to invoke here. So now you have an electronic file, this 3D thing that you'd like made, and we'd like to go get that made. You have a lot of decisions here with where to go, from that to get things done. We've got a couple great resources which are targeted specifically to the model railroad community. We've got the model railroad resource, the 3D division of such, which you might not be aware of, but there's the link right there. And Dan Dowdy and Amy can help you, and you mail them your file, and they've got printers there, and they can produce small runs for your favorite part for your favorite railroad. They're set up very well to do that. There's also 3D Central, link right there. And I'll mention, both Dan and Amy's site as well as 3D Central. They already have shops with plenty of and ever growing O scale 3D details ready to go, just in stock, and also on demand ordering. So you might find what you're looking for there, but you can always email them a file and they can bid the job out for you and do the printing for you. There's also non-railroading commercial sites. So there's Shapeways, which went out of business for the last couple of years, but now they're back in business. Can be somewhat pricey, but they will do some of the weirder things, like we'll get into here in a second, like printing metals and such. So they can be good for some of the esoteric work. There's also Craft Cloud, which is really, it's not one place. It's a confederation of many different vendors, many different capabilities that all kind of bid on your project. It only takes about 10 seconds to upload the file and see how much it costs for one, how much it costs for 10 and 100 and so. And they're a good option. There's always Find a Buddy with a Printer. Back to the 12-year-old kid next door. That's a good way to incentivize them to take on some model railroading work. And then, of course, doing it yourself if you own your own 3D printer. What I want you to know about this is I use every single one of these options. They're all good. They all have their strengths. I do own a 3D printer, but just for doing basic prototyping. I can't really do production work. But there's benefits and trade-offs, to each and every one of these solutions for getting it done. But let's go down that last option. Let's say you own a 3D printer. You went out and you bought one. Got one for Christmas coming up, and you want to take that STL file, send it to your printer, hit go, and wake up the next morning and check out your cool new part for your favorite railroad. There's one intermediate step that you have to do, and that is to create the machine code, the actual code that tells the printer what to do. This is computer-aided machining, the difference between CAD and CAM. And the good news is, even though it's one extra step to do, the software is all free. I happen to use a piece of software called Lychee, but there's many others out there. This is what I've chosen to learn how to do. But what you're doing in this step is you're taking that 3D file, and here you can see the Cleveland Terminal Tower, really small, and you're determining what orientation the pose of the object within that 3D printer, and you're adding a bunch of structural elements. Think of them as sprues, just like building a model kit. You have to add all that sprue material to help support the model against gravity while it's being printed. Maybe you want a hollow part. This would be a good candidate for making something hollow that doesn't need to be all full of resin. We could save a lot of resin if we hollow it out. This program here will allow you to do that. And here's where we choose some of the print settings. Every printer is going to be a little bit different. Every resin is going to be a little bit different. And so the print settings are the ways to fine tune your printer performance and capability. I'll share with you some of my print settings here in a second, but all that is done in this slicer software. And so slicing is basically the software is going to take your design as you see it right here, maybe Greg's tree or the terminal tower, and you're going to determine how thick each slice is going to be while we print this file out. So you can imagine taking a knife and cutting horizontal slices across these 3D objects. And every time you take a slice, you'll get a profile, a two-dimensional profile, which what the printer is going to do is it is going to fire the ultraviolet LEDs in the same pattern as that two-dimensional slice. And then it's going to retract the part and then print the next slice and retract the part and print the next slice. So the software performs the slicing and makes the instruction set that gets sent to your printer on your thumb drive. That's essentially what we're doing here. Okay, so let's get to the printers themselves. There are many kinds of different printers, many different print technologies. I'm just going to focus on two that are the most predominant here for model railroading. On the left, we have resin printing, and on the right, we have filament printing. We'll compare them both. So resin printing on the left, you see we have a vat of liquid resin. You can see the elevator is above it. So that runs up and down on a lead screw. The LEDs are underneath, and they're going to fire the LEDs, cure the resin for a thin layer, and then retract up and cure the next layer, retract up and cure the next layer. And we end up revealing the part basically upside down. It takes many, many hours. It's very slow, but it's the best for generating fine detail and smooth surfaces. So a lot of our detail parts, much of what you've already seen in this presentation was generated with the resin printing technology. There are water-soluble resins, although in my experience, like anything, water-soluble doesn't work as well. So I don't use them, just like soldering fluxes. So for that reason, they're stinky, they're toxic, they're messy, and so you have to don the right PPE to work with them. On the right-hand side, we have filament printing. So filament is just you go buy a spool of plastic and you feed it into the machine, similar to like a MIG welder. And at the tip of the machine gets hot, it melts the filament, just keeps feeding that filament material in, and through additive manufacturing, just deposits the material down. This is really popular for kids. A lot of classrooms in elementary schools have one of these filament printers right now, and they're learning how to do this. One cool thing for kids is that it immediately prints the colors that you want. You buy the spool of material in those colors, and it can switch colors while it's printing. I think this is a great technology for model railroading for large elements, particularly concrete. So you can see in the center here, the bridge piers for the Cuyahoga approach, that was all done using filament printing. You do get little striations left on the part. I actually like the striations. I think it looks just like poured concrete. And so I think it's a perfect thing, for that. And again, if you're trying to get some kids involved, the filament printing is a great entry point, for 3D printing. And it's really good for large parts and very affordable. But let's go back to the resin here. So here's my print setup on the left-hand side. This is one of my workbenches. And you can see in the center, I have a very low-cost printer. It's $175 made by Elegoo. That's done almost everything that you've seen in all these pictures, except for the larger stuff. And I use a resin there by a company called Frozen, but none of that's the important or interesting stuff. The important thing is the tools. You don't have to buy expensive 3D printed tools. The most important tools I've highlighted right here. I put a toilet paper roll right over my printer. You don't have to waste expensive microfiber cloths the way all the YouTubers are saying. Just use toilet paper. That cleans up everything really well. It's biodegradable. It's great. Barbecue tongs, that's how I handle everything. Barbecue pans, that's where I work out of with everything to help contain any of the mess and the cleanup of the mess. And then finally, a scalpel. Generally, we don't use scalpel blades in modeling, but for 3D printing, they're really helpful for freeing the parts away from the print surface. In the upper right-hand corner, you can see a bunch of parts as they appear when they're done being printed, and the scalpel can perfectly get behind there without marring up the print surface or, cutting into your part, and then you can give it a little twist and the parts, pop free down in your barbecue pan that you bought from Walmart for $2. So keeping costs low, as possible is the name of the game. Generally, I'll use gloves, although, for pictures, I'm just, showing you here with bare hands handling everything. But like I said, until things are cured, these are toxic chemicals that we're working with here. Okay, I didn't want to go into the details here, but just to show you, maybe take a screenshot or you'll have the PDF. I'll post it here in a few minutes when we wrap up here. Here are my typical print settings that are set in the slicer. I typically go with 20 micrometer slices and shows you the exposure time. Each one of those slices, we fire the LEDs for 1.1 seconds. That seems to work with this frozen goo. But, if you switch to a different brand, or if I, go off the beaten path and try to print something weird, then these settings will change. But these are the middle of the road settings that might help you, so you're not having to iterate from zero. The key takeaway, all I wanted to say about this is that thin layers means it's going to take a really long time, but you're going to have a nice smooth surface, and slow and low, just like a barbecue. That's what makes nice objects when you're done. The first thing we'll do when we remove the parts from the printer is we want to wash them immediately.
Daniel, you appear to be frozen. How do we undo this?
I think it's on his side, David.
Okay,
Can you hear me yet?
Yeah, we can hear you now.
Oh, great. Yep.
You were frozen for a few seconds. We're not talking about the resin brand, but actually frozen.
Yes, thank you. Yeah, I just got a note here. My internet connection is unstable. All right, I got a chipmunk chewing on the wire out there. Okay, so after thank you for the heads up on that. So after we're printed and we remove the parts, the first thing we want to do is rinse the excess resin off. You don't have to buy a fancy wash station. You can just do it manually in a cup of isopropyl alcohol. But you are seeing some parts there in a basket being rinsed off in alcohol. The point I wanted to make here is the parts aren't fully cured yet. They're cured just enough to hold together, but they're still kind of pliable. You could push your nail into the side. And this is great because if you need to do any shaving or machining or drilling on the part, now's a perfect time to do it because they're just very easy to work with. I use just nail files, for shaping things. Clipping all those sprues off as well. This is a good opportunity to use some sprue cutters so you can get in nice and close and trim away all that support material, and then throw it in the wash station. And that only has to go for 3 or 4 minutes, and you'll get all that excess resin off. From there, we let the parts air dry, and then we cure them with UV light. Now you can go buy a UV light like you see in the right hand or left hand corner here, or you can just leave them out in the sunlight on a windowsill for a couple days because the sun has UV in the spectrum, and that'll cure them just as well. Either way, this will have a perfectly cured part, and now they'll be nice and hard, and you can start using your conventional glues and modeling techniques for assembling things together and integrating them with the rest of your model. Here's some pitfalls, some things to watch for when things go wrong. Here's 3 of the main things. Sometimes you'll print and you'll see that there's striations. It'll look like strata, on a cliff, and that you can see that in the top left-hand corner here. Typically, you'll see these on curved objects, right? And that means that you didn't have thin enough slices on your slicing software. And so you can reduce the thickness of the slices, and you can see they went from 100 to 50 to 10 micrometers, and it took 14 hours, but they got a nice smooth part. There's no free lunch here. Or in the top right, you can see where I tried to print one of those signals and the base ripped right off in the printer. All right. And so that tells me, oh, I didn't have enough support structure around the concrete base. So I have to go back and add some more of that structural sprue material, and then that'll form up okay. Of course, the penalty for that is I have to clip now that many more supports when we go to remove the object, from the sprue material. Or in the case of the lower right-hand corner, again, on curved objects, you might see the faceting going around like you see on that boiler. And that means that when you exported the file from your design program, we didn't have a high enough setting in the mesh resolution. So we can just move that slider over. Now, the penalty for that is our file gets very big. So maybe we can't email it around to people anymore, but that will make a nice smooth part. These are three of the most common things that you'll see, which can be frustrating the first time you see it. But I will tell you, failure is kind of the norm when you're, even now, I never expect the first time to just magically turn out when I print things. It's always going to tell me what's wrong. If I know how to read it, interpret it, and maybe the second time or the third time, we'll get things tuned up and ready to go in a better fashion. But let's show you some success stories now, some really interesting and pleasant surprises that I've found. So I bought a bottle of the clear resin just to play around with, and you can see in the top left-hand corner there, I made the terminal tower and I made some emblems there for the nickel plate in New York Central. Really cool. Just as fun, desktop things, and just like a light tube, you can put a little LED under it from Amazon for $5, and you have something that looks really nice. But thinking about practical ways to use this, you can see in the center here, this is the GE 44 tonners. Some lines used illuminated number boards. They had a little number board hood extension come out the front. So if you print that in clear, and then paint it and decal it, but mask off the number board before the decaling, now you can have illuminated number boards with clear resin. Or on the right-hand side, here I'm trying to make some of those gorgeous convex lenses on the Mars lights, which would have been clear or red, depending on the rail line and the application, front or rear of the train. So now we can print out custom lenses that way too, which is hugely helpful. Again, favorite part for your favorite railroad. If your railroad used Mars lights, that's like the first thing your eye goes to on the front of the engine when you're looking at it. So nice to have lenses for it. Taking it a step further, how about metals? This is from the jewelry industry, spin casting. We all know about lost wax brass, and we've all benefited from people who have dedicated their lives into making those parts from us, going back to the old Chemtron days and such. 3D printing can have a role in that as well. So in the top left, you can see some resin-based louvers for the NW2, and those were used as mold masters for brass spin casting. So this is a multi-step process, but we can take our 3D printed part and then use that as a mold master, which is basically going to have plaster poured around it. And then the resin is removed from that because it's a castable, resin, leaving a vacancy, which then that entire mold gets put down into the centrifugal device that you see at the bottom, spun up, and liquid metal, brass in that case, gets poured in, and the centrifugal force forces the material into all of the voids, creating that gorgeous brass louver that you see at the top there. And this was mind-blowing to me to see this. This is where I really love the idea of multiple technologies, old and new, coming together to realize some things that we never could in the past. Equally interesting is the idea of direct printing metals. So you can see some stainless printing here on the right. I needed a center beam for a flat car, but trying to get mass to a flat car is always the challenge. So could we make the center beam and bolster in one part? out of sintered stainless steel? The answer is yes. And then you can see the Hewlett buckets I had done, and even did the 20th Century Limited tail sign. This is all direct printed right from stainless steel. So we can use them as casting masters on the left, or with other metals like stainless steel, we can go directly, to the material as well. Pleasant surprises. Along those lines, here's something I'm working on right now. You've seen the Hewlett that I've been one piece at a time trying to make advances on. I'm trying to make one operational. I don't know if it's possible, but the bucket open and closed with these enormous pull chains, pull to open and pull to close, two different sets. And on the right hand, you can see I just got these in a day ago here. These are printed in rubber material, so now they're pliable. So I can turn a roller chain into basically a belt. Maybe I can affix this to the bucket. Will it be strong enough to actually pull the bucket open and closed and wrap around the pulleys? I don't know, but we're going to try and see. But we can print things that are pliable, and here's a neat model railroad application, for that. So in conclusion, if you're still hanging along with me, here's some lessons that I've learned, and here a couple projects up top. Here's a couple steamers that I've been helping people and working on, trying to correct the deficient Mohawk sandboxes, and all the Mohawk smokestacks are wrong. Not anymore. I got your smokestack to fix them all, and a little 10-wheeler in the top right. I don't think 3D printing is like the definitive future of our hobby. I think it integrates really, really well with it. It is going to be a major part of the future of our hobby. I think the older modeling techniques, working with brass, working with styrene, working with steel, are always going to be there. And the real, key is making this all work together. Sometimes it makes sense to use steel as handrails, things like that, and gears, right? But 3D printing can help us maybe take less machining steps. Maybe we can prototype some brass gears. Maybe we can help prototype some gear boxes so that we can make new drive lines in that way, and make everything kind of work together. It's great, as you've seen in all these parts, it's great for complex geometries, and mass producing them, at least as a small run. I like soldering very much. I'm fairly good at it. It's one of the few things in life I'm good at. I can solder one of those catenary towers. It would probably take me a month or two to hand solder that with a resistance rig, but then I would have one tower. And so how long would it take me to have a dozen towers? A couple years, right? And I don't want to do that. Making one might be fun, making a dozen, not so fun. And so it's really good for niche stuff, especially complex niche things. And Greg had his 3D printed tree presentation not too long ago. Perfect example of it. Or these steamers here, maybe just making a replacement 3D boiler, but integrating that with brass detail to make a steamer that wasn't previously offered. The last thing that I wanted to say here is if you're printing something for yourself, or you're buying something 3D printed from someone else, try to keep them out of the sunlight until you've got some primer or paint on them. Remember, ultraviolet light is what cures them, but even after they're cured, that ultraviolet light is going to continue to change the composition of the material, and it's going to get harder and harder and eventually embrittled over time, and it might not be usable. So for longevity, if you're going to buy some stuff, but it's not going to be used in a project, put it away in a box, or at least, put some primer on it and put it away, for later. Okay, and then just a couple more things here. Here's some things I haven't shown you that I'm working on right now. I've started working on the Blomberg B trucks. I've got the frame already done on that, and I'm going after the plain bearing first, and we'll do the roller bearing after that. But the plain bearing, that's a rare bird. So that's a again perfect thing for doing in 3D printing. Some operational train order signals. That's fun. I got a big 1/5 scale train order lever that works. It's spring loaded. I'll have that at the upcoming Cleveland show here in a few weeks. And some of these other things as well. And I'm working on a Fairmont speeder and a little tugboat that the Wheeling owned for bringing the ore boats in and out of the Hewletts up there in Huron, Ohio. And that's my full presentation. Again, I'll mention everything that you've seen here. You can download to the right at that GitHub site. There's a file repository. You can again take a picture of the QR code, and that'll take you over there. And then again, I will be at the Cleveland show. I only have a little 3D printer, so I can't really produce things just for prototyping. But I always will try to have a few things at the Cleveland show that I can sell there. And you'll see my little emblem on there. It's the Omega for Ohm, Omega Model Railroad Products. And very, very lastly, all this is building on the shoulders of others. Some of whom are on this call right now, who have helped me get the information that I need to make these things a reality. I can't imagine any of the gentlemen that you see here, knew of 3D printing or what it would do or how it would be in the hobby, but they were all very talented in their own way and had the forethought to document a world that didn't exist during my lifetime. And I'm ever thankful for them and those of you on the call for helping me with the industrial archaeology and helping put all these puzzle pieces together so, we can enjoy our favorite parts, for our favorite railroads, in the end. And that's everything I had for you. So thank you for your time. And like I mentioned, I'll post this in the chat as a PDF, and happy to take any questions if there's time. If anyone took no-dos and they're still with us.
We have time. I need to be able to call on people one at a time, and I'm afraid that the screen share blocks off all of the pictures of people's faces. So is it okay?
Oh, yes, absolutely.
Stop sharing at this point. Okay. Let's do that, and that should bring people back. Okay. Now, I note if you go down to the bottom of your screen, to the right of where it says participants, there is a little, like a cartoon bubble that says chat. And if you look to the right, if you click that, you will see both Daniel's PDF and what is that other thing? Adobe. And you'll also see a couple of notes from Scott Thornton and then some follow-on from Daniel. So feel free to use that. What I'm going to do at this point is to see if I can reconfigure the way we view. Let's do gallery, and that will give us faces. And what I would ask is if you have a video, a facial shot, and you want to ask a question, please put your hand up like this, and I will call on you. All right, I see Carl Sorensen is our first questioner. You did it right. There are some people on the call who do not have their video on, and we'll go with the people who do have their video on first, but then we will try and do a more formal, more informal calling on people after we've had the video. Boy, I'm really screwing that explanation up. Sorry about that. Anyway, we'll start with Carl Sorensen, who is perfectly good, except that he's muted. So whatever he asks us is not going to come through. So unmute yourself if you would, Carl.
I'll use the space bar. Daniel, I'm sorry I missed the first half. I didn't set my alarm today, so I got the from 3 o'clock on when my phone told me about this. So as you can see, I have a motor car in the background, and one of my big dreams, I've got a lot of learning to do, is to 3D print that motor car in the background. My question to you is, did you put a little motor on your motor car, or you just did a motor car?
That it's in process right now. there's two motor cars in my local vicinity over at the Mad River Museum in Bellevue, Ohio. And I like the older of the two. That doesn't even have a nameplate on it, but that's the one I really took all the measurements from. And I'm doing the engine as well. It's got the older, smaller engine, which is just cool. It's very interesting to me. So yeah, I'm doing everything bolt for bolt from the ground up, and it's one of those things I was hoping to have done by the Cleveland show in 2 weeks, but I got into too many other orthogonal projects. But I will be making that file available, and I'm sure that looks like a more modern, larger thing over your shoulder than what I'm
Yeah,
working on.
it's an MT-19.
But I'm sure there's a lot of similarity in it. So anything that you could reuse from what I'm doing, you're more than welcome to. I always post everything, up on the site. So
Well, I hope to power it, and I'm a dead railer too, and so I'm hoping to dead rail it with the trailer behind it.
mhm.
And so that I'm always looking at what people are doing on speeders, and I've got a few 3D printed speeders, but this one I'm hoping, like I said, put a little motor in there, whether it's N scale or what, and then have a trailer to haul the battery and the controller. So, but I
Gotcha.
appreciate and hope to talk to you again about this.
Sure. Yeah. Once I'm done, well, I'd like to have a static one and I want to have one powered. So I'll do both. But the real engine in it is so cool. And so I'm modeling the entire engine and everything because it'll just look awesome with
Is it
the
a one
model.
lunger, one
Pardon?
cylinder? Is it a
Well,
one
oh yeah, yeah,
cylinder?
yep, yeah. It's one of the hit and miss. Yep. They were given rides at Sugar Creek at the Roundhouse, and you could get on those things, and they'd take you out to the turntable and spin you around. And brought my kids, and it was awesome. So I'm like, I got to draw this engine. This is great. But yeah, I'll make another one that's hogged out, and then you can put a drive, whatever you want, under it as well. But what I really want to say is, out of Bellevue, they also have on one of the flat cars after it, they have a great mechanical crane. And so that'll be after the speeder is done. I got to make this flat with the crane on top. It's very, very cool.
Are you
Well, thank you, Dan.
contemplating a Stanton drive for those?
Actually, I was looking at the 10 Shoto HO drives, which are wonderful runners, and they go for a song on eBay. Very smooth, and you can just knock the HO wheels off and extend the axle out, and it'll be perfect for a speeder.
Thank you. Other questions? Hold up your hands if you would. If you got video, I see Greg is there. And then we'll go to Kim Mosney. But Greg? Greg?
Can you hear me now?
Hear you now.
Great. Dan, what about using brass casting for some of those really delicate tower structures with the lattice work? Would you consider that?
Yeah, there's a an optimum point for brass from a cost perspective. And then when you start to get physically larger, it goes like exponentially up in cost because a lot of these spin casters, as you know, are from the jewelry industry. So they're very limited in their volumetric, capacity. So I have tried to get some bids for larger things. And it looked like once you get to the size of like a locomotive frame or, a 50-foot boxcar or something about like that, the brass just gets too expensive because almost nobody actually owns a caster big enough to do it. And then the price goes way up. So, the smaller parts, you're making a bell or a louver, the cost can be very low. But then when you get larger, that's where the stainless steel starts to become a better attractive option, except with stainless, you can't get the fidelity. So I think stainless is going to be great for like underframes. You want the cabling for the traction motors and the gussets and plates and all that. Print it in stainless, and it won't be that expensive. Yeah, the brass seems to get prohibitively expensive to try to do like a whole tower with.
Ken Mosney?
Thank you.
Yeah, I've done a fair amount of 3D printing myself on a resin printer. And one problem I'm having right now is I'm struggling with, first of all, I work in HO, is keeping large things flat. I've got a tender frame, which for an HO switcher that I've printed several times, and large flat things always seem to warp. And I just wonder if you have any suggestions for keeping things flat. I it, Putting ribs or something like that is kind of out of the question because of space constraints. And also, besides say a tender frame, things like a car shell
Mhm.
or a locomotive shell. Have you ever tried these, and what techniques do you use to keep things straight and flat and preventing from warping?
Are you getting the warping? Are you talking about warping like weeks after the fact, or like soon
No.
after printing within a day or two?
Well, warping right after printing. Um, the best technique I've found right now for this tender frame is I take it out of the printer while it's still soft. I strip the supports off. I sand the top side, which is where the supports are flat, on a piece of sandpaper to make it nice. And then I clamp the part to a flat piece of wood
Hmm.
and cure it flat. And
Yes.
that seems to help. If I
Yes.
cure it just free, it will warp, and I haven't found a way of getting it straight.
Yes, I'm with you now. Yes, I've
Yeah.
had this issue. So a couple things. If you're trying to do something flat and thin, you're going to have this issue. Two gotchas definitely are not letting it dry, fully dry before curing. And by that I mean if I'm going to do something thin, like those DT and I emblems, perfect example. Those are as thin as my printer can do.
Hmm.
And if they curl a little bit, it'll be very noticeable. I'll let those dry for like 2 days in the dark to make sure that all the alcohol is out of there. And I won't hit them with a heat gun and try to, no, just air dry in a cardboard box away from the light. Because if you try to cure something and it still has any of that alcohol still in it, it's going to take off like a potato chip. So that's one thing. Make sure everything is completely dry. The other thing, as you start to kind of get to in strapping it down to, a piece of wood or whatever, sometimes I won't remove all that support structure if I think I'm going to have a warping problem. I'll leave it attached and fully cure it and then go remove the support structure. And as you know, that has its own issues because now we're clipping things when it's harder and we don't want to remove material. So that's another strategy. The last thing is if you're going to cure something and you think it's going to warp, don't cure it all in one time either. It actually gets fairly warm in there in the cure station. So I'll only cure like 30 seconds at a time and then I'll let it cool off for a minute. And then I'll hit it for another 30 seconds and let it, well, lift the lid and let it cool off and maybe flip it upside and downside. I also used some of that silver tape on the bottom of my UV light. So the light kind of bounces around inside there. It's not getting all the energy from one side. But I'll also kind of, barbecue roll it as well and just hit it, 30 seconds at a time. All these things kind of together, I think have minimized that. But in the end, if I was doing a frame like my flat car, for example, even if it's straight, I'll go in and just epoxy some small 1/16 inch brass tubing, inside the channel or somewhere where you won't see it, and that'll make sure that it doesn't take off.
Well, I did try that with the tender frame. I actually I tried one where I printed some grooves in the top of the frame
Hmm.
and epoxied some brass pieces of bar stock, 16th inch
Perfect.
square. Didn't work.
It didn't work.
No, it didn't work.
Did the epoxy come loose?
No, it just wasn't strong enough, rigid enough to flatten it out.
Oh,
Is
okay.
my take on it.
I've
Yeah.
always used tubular shapes.
Yeah.
I've got a lot of that from the model airplane stuff. I got a whole KNS
Yeah,
display basically.
I've got a KNS Hobby Shop's worth too.
Yeah, yes. I find the tubular shapes won't deflect. They won't, pull to the side
Mhm.
like that. But, I think there's no one strategy. It kind of depends on the part. But yeah, it is an issue and something that now I've gained enough intuition where I kind of can anticipate where I will have a problem part and start thinking about a strategy against the warping.
Yeah.
Right.
Okay, thank you.
We need to move along. We got time for a couple more questions. I see Eric Peterson and then Jim Cantor.
All
Eric?
right, I have a couple. First of all, fairly simple, I guess. Once you have something, maybe you purchased from somebody in an STL format, can I then go back and modify that uh, in the Fusion um, before I send it to be sliced and printed?
Absolutely. Yeah. And I do this myself too. Like if I have two different projects and then I want to put them together into one single project, let's say I made a headlight over here and then I got a different engine that wants that headlight, then I can export it as an STL, bring it on in, modify it. Absolutely. The only thing you don't have when you do that is you don't have the history of the STL. So you can't just like hit your undo button and go back. I don't find that to be a problem. I just need to like hack off a little bit or add on a little bit of something new to the STL. And you don't have to use Fusion. Any of the software would allow you to remanipulate things.
Okay. And my second question, I'm worked in the signal business with Union Switch and Signal equipment, so I'm very interested in your signals. And did you make provisions to light them and to wire them as part of the project?
I did not as of yet. My first ambition was to just try to make a scale signal, which I thought was a pretty high bar in the first place. It's a 5-inch diameter mast after it next down from 6 to 5. And I said, I want a signal that looks great in the foreground of a picture. Let's shoot for that. And now we finally got there. So can it be lit? I don't know. I will try to hollow out the shaft and we'll see. But they're already very lacy, very delicate. Once that becomes a hollow shaft, there's a lot of. I like to talk with you offline, maybe more about it because there's a
Yeah,
zillion
okay.
options here.
Yeah, I'd be glad to work with you on that because I'm very interested in, especially being able to get US&S signal heads like you have already done.
Mhm.
And there may be ways to do it, especially with the clear resin you mentioned before. And
Well,
then
you can
just
do it.
drill and,
You can
and
do
put
you can do the
put a
lighting.
small LED in, excuse me, and put a small LED in the back or something. But I'll contact you separately and we can work on
Eric,
that.
you can do the lighting with fiber optics. That's probably the easiest way to do it.
I don't think you can do all the bends with fiber optics.
Okay.
All right,
That
that's my
sounds like
question.
a question for follow-up. By the way, you can ask questions during the chat printed and get responses that way. So if there are carryover questions either for later in this program or you want to leave an email and get a follow-up, that'd be great. Last question, Jim Cantor. You need to unmute yourself. Thank you.
Daniel, in one of your photographs, you had a locomotive in the upper right-hand corner. What locomotive is that? Number one. And number two is I really thank you for your presentation today. It was very informative.
Thank you, Jim. Well, I'm going to send you a royalty check since you appeared in it. If it's the locomotive I'm thinking of, that's number 44 from Steamtown. That's what I've been pretty immersed in this past week, putting together, trying to make that a reality.
Well, send my royalty check to O-Scale Central.
That will do.
You're the man. Okay, we need to move along. Really appreciate Daniel's presentation. He is a fantastic guy. And as I indicated, not only is he thoroughly competent in his art, but he has the ability to explain it to those of us who are not techies, which is at least equally important. Daniel will be at the Cleveland show. If you have not contemplated going there, maybe you should, because he's going to bring a whole bunch of stuff. There will be a lot of other folks as well who will be at Cleveland. And by the way, I note that Skylar Shippey, who is not only president of O-Scale Central, but is the coordinator for the Cleveland show, is on the call at the end of the program. If Skylar has any announcements he needs to make, we'll give him the opportunity to do that. But that is the next event coming up. Our second presentation is regarding modular standards and modular organization. And I had indicated at the outset of the program that Nick Bulgarino will be taking that on, and gave him some background, gave some background both on Nick and on the modular program and where it fits in. So Nick Bulgarino, tell us what you got.
Will do. Hello, everybody. I'm Nick. I'm the O-Scale Central Vice President, and today I'm going to talk about the modular standards. The committee that's been making these standards for O-Scale Central is Philip Taylor. He's the NMRA Superintendent of the James River Division. Skylar Shippey, who's the O-Scale Central President, as David just said, who has been on this call, as well as myself, Eric Peterson, and Rich Randall. Both of you guys are also on the call, so hello. We have 4/5 of the committee here. Today, what I want to do is just show you where we're at right now with the standards, talk about what the physical modules are going to look like, and then talk about organizing local modular groups so that if you're interested in starting one or joining one in your area, there are some resources there for you. I'm going to share my screen here. And that's not the one I wanted to start with. I want to start with this one. All right, so the goal with these modules is to make something that is strong, durable, but also lightweight. So I want to start by talking about the blueprints that you see here. Skylar, Eric, and Rich, if you guys want to chime in at any point since you're on the committee, feel free. But I want to start off with the basic requirements of the system, which is what you see here. So this is the basic module design. Skylar drew this up in CAD for us. So I'm going to zoom in. Can everybody see, by the way?
Yeah.
All right. So I'm going to zoom in a little bit here. So the basic module is going to be 4 feet long. And the minimum depth requirement is 2 feet. So the reason we chose this is, this is the smallest, lightest construction that you can make with the wood as we have it. Where is the other standard here? So these the exception here is going to be for bridge modules, which I'll tag in Skylar to talk about in a moment. So right here, we're recommending that holes are going to be drilled for the bus wire, so that way you can organize a little bit better. Let me see what else I have here. Let me zoom out for 1 second. Here, pardon me, I need to go grab my script. I left it over in my backpack. 1 moment. Oh, never mind, it's not here today. All right, so here's what I'm going to do in the meantime. Wait, wrong document. Okay. So these are this is the draft standard. We don't have this available yet for comment. We sent out an original standard a while ago for comment in the coupler. But basically where we're at right now is the first version of the standard is going to talk about strictly double track mainline. So we're not addressing branch lines. We're not addressing trolley, since that's East Penn's territory. They already have a good standard for that. But what we are talking about is double track standard main. The smallest radius for this is going to be 72 inches, and we have a simplified document here that talks about this stuff. This is available, and I will explain where it's available in a moment. But as you can see, well, maybe you can, it's a little bit small. The basics of the standard will be the tables are going to be 48 inches from top of rail to the floor, so 4 feet. So that way everything's nice and accessible and viewable. The framing end plate, that's going to be 3/4 inches thick, 2.5 tall, and that's referencing down here, going back to this. Again, the system is going to be based off of 4 feet. So you can have a 12-foot seam based off and have 2 6-foot modules put together. But the total length has to be 12 feet because that's divisible by 4. So you can have 2 6-foot modules making up that one seam, but we had to pick a base unit. So base unit is going to be 4 because this is the smallest reasonable that can be transported by most cars. I'm going to talk a little bit now about the wiring, and Eric, I might tap you in to talk about wiring here. We're going with Anderson power pole connectors. This is something that most other scales use. I'm going to increase this in size a little bit here. This coloring scheme, if you are familiar with other modular standards, is more or less the NMRA standard that was adopted from NTRAC. So that way this increases the ability for other people who have been in other modular standards. Let's say you've been playing around in NTRAC. Well, this should be pretty familiar to you. That way we can help other people and other people can help us if we have questions, since we're following more or less the same wiring. So Anderson power poles, there's going to be the why am I blanking on the name of the screw terminals at each end? There we go. So there's going to be screw terminals at each end of the modules. There's going to be a bus wire running across, 1 per main. And then you're just wiring the ends of the modules unless you want to put in maybe a frog juicer in the middle. That's something that we leave up to you to decide if you have switches or a crossover. So now what I want to do is I want to talk about this in a little bit more depth. So this is the PowerPoint that I have to talk about kind of the Maryland group specifically that we're starting. The background here is the original hand sketch that I did for when we adapted Tony Custer's Wingate modules into this new standard. So the Maryland group that's doing this is called Maryland Modular Modelers. That is the group that David and I have co-founded to help in the Maryland area produce or to spread the scale, or I'm sorry, not spread scale, to spread the standard. Rich has a group in southern PA, South Central PA. So the whole point of the group that we are starting, and this is kind of something that I want to promote in terms of community building for you locally, is, number one, always have fun. Kalmbach says model railroading is fun. So might as well, adopt that as part of our mantra. We want to build a team, which helps make the hobby more fun. People make the hobby fun, not the trains themselves. And of course, we want to develop our modeling skills. There's lots of aspects that go into building a model railroad. I like to say it takes a village to raise a model railroad. And also increases the visibility of the hobby for the scale. And that's something that we at O-Scale Central have been doing a lot of lately, is trying to get back into the mainstream of the hobby. NMRA has been a very good partner in that. And this is only going to help further that. So if you're looking for arguments on why to do modules, modules are becoming more popular across all scales. There are multiple standards in a couple scales. I know HO has a few, FREMO, as well as the NMRA module standard. NTRAC has T-TRAC, NTRAC, and a few others. But, this is kind of a response to where we are right now. There's a lack of space for permanent layouts for a lot of younger modelers. We don't have, access to large permanent private spaces to build our own stuff, and clubs are getting harder and harder to find. Um, we also need to be a little bit more mobile. If you're doing apartment living, modules would be good for you. Builds are smaller, and you can also build them faster. That's something I forgot to include in this slide. So if you want to build a scene, which is, if you want to build a certain prototype scene, you have the ability to isolate an area, model it in very high detail, and it's a small, manageable build. You're not looking at an entire basement and saying, "Wow, I have to do 5 trees per foot per physical foot, or 10 trees per foot, all the way down this 30-foot span of wall." This is a smaller build. They're also easy to store and transport. Um, you can stand them on their side, put them out of the way when you're not working on them. And you also get to be part of a larger model railroad. Something that we talk about in the committee every now and then is how cool it would be to see 100 feet of track, just dead straight, long train being pulled on it. I think that would be pretty cool. So one way you can organize your groups, this is how I'm choosing to do it. There are benefits and druthers, if you will, to doing it this way. But I'm trying to keep things informal. So there's no dues, there's no membership meetings, quote unquote membership meetings. Of course, we're going to meet. And there's no bylaws, procedures, treasury, none of that. The group is going to decide what we build, when we build, and where we're going to go, or at least who we're going to reach out to. And participation is at will, meaning if you're not able to make something, it's not there's no risk of termination from the group. Build module and bring. So one way that we're trying to increase visibility of the scale using this group in the capital region, DC, Baltimore, is you can participate with us without having your own O-scale equipment or modules. So the idea here is, let's entice some of the smaller scalers who are not necessarily sold on the scale by using this medium that most people know, which is modules. Bring them in, have them operate with us, and say, okay, maybe I might want to get invested in building my own modules, or building a scale, or building in the scale, getting my own O-scale equipment. And if you're interested in the website, which this is where the current revision of some of the documents, again, not all, but the current revision of some of the documents are at marylandmodularmodelers.com. And you can click join us, give me your email, and then you'll get more information on how we are doing things in Maryland. So this is the first version of the layout that we're building. And as you can see, I tried to darken it. Can everybody see the track plan? All right, good. So the basic or the idea for the start of any modular railroad is you got to have an oval of some kind. You got to have a yard of some kind. You need to be able to stage trains. You need to have corners. Now, notably, the standard does not talk about the construction of the modules for corners. The reason that we decided not to do that is there are just too many approaches to the bench work. So long as the end plates meet the standard, you can build curved bench work. The Detroit Model Railroad Club, which Skylar, I'll tap you in to talk about your layout, your modular layout here in a second. But that layout has corners that are, the track is obviously curved, but the bench work is not. And I'll have Skylar talk about that in a little bit. But we don't dictate what the bench work is for the corners. We only dictate that the minimum radius for your curve for the mainline modules is 72 inches. Now, you can go larger than that. There's no problem going larger than that. But the minimum to qualify as a mainline module is 72 inches. Skylar, can I tap you in to talk about the Detroit Model Railroad Club modular layout?
Sure. I don't have any visual aids at the moment, but we built a modular layout in 2022, buying the benchwork and plywood when it was about its most expensive. The corners were designed to be cut to where you can get 2 pieces out of a 4x8 sheet, and they're trapezoidal in shape. So when they fit together, they there's 90-degree corners. So 2 modules make a 90-degree turn, if you will. We built a double-tracked oval. It's about 31 feet by 15 long, 4.5-inch center, which was decided almost on Facebook that summer. So built out of necessity because we needed to publicize our club at revolving meets in the state, because it's kind of hard to move our permanent layout. But yeah, that was the general idea for building ours. So building the corners is going to be specific to the regional group who's ever hosting the event. Either they would make their own, or they would conjure up somebody to bring the set of corners. The other thing too in the standards is the minimum radius, which is 72 inches. This was decided so that anybody can run pretty much anything they want. We don't want to limit based on just a radius, especially when this is not going to be in a basement, but likely in a gymnasium or some other type of meet location. So yeah, that's pretty much it from the Detroit perspective.
Gotcha. Thank you. I'll just move on to the next slide here. So normally this kind of presentation is given at an all-scale meet. So I don't think I need to explain this slide to anybody here. But obviously O-scale is a great scale to model in, and it's about time that we had, as a scale, a standard that we can go to shows, build to, set up, and display our models. So again, this is the benchwork document. I think I mentioned this before, but 4.5-inch centers, that's another thing with the track spacing. Again, that's done to kind of be a compromise between your steam era modelers and your modern modelers. 4.5 inches is good. That also is the minimum for, I believe it's 89-foot freight cars passing each other and a big boy. So you get clearance there on the 72-inch radius curves. So it's nice, and it's kind of a good medium between everything. Another thing to mention about the bench work is that we do not specify what legs you're using. Skylar here has modeled what they have in Detroit, which is that box, was it 2x2 and then a box to hold it, and then you screw in the thing there, right?
Yeah, just a housing in the corners with a through hole. We use bolts to hold them when tipping them over. So nothing complicated.
But there are so many approaches to legs, and people have their preferred way of doing it, opinions, gadgets, gizmos, that we decided, we're not gonna strictly enforce, you have to build this style of leg. It just needs to be strong. And that's something that we are going to leave up to the local organizers for now, at least. If the need arises, we can go back and revise. Again, I showed you guys the wiring diagram already. This is familiar to anybody who is currently working in any of the other major modular standards across scales. And then finally, just to show you guys what these standards look like, this is the adaptation of Tony Custer's Wingate modules that we made for, this is the Mid-Atlantic show, Mid-Atlantic RPM. So as you can see, what we have, actually what's pretty funny about this turntable here, and David, this was his idea, is a Cupcake Lazy Susan that has track on it. It's not motorized, but you can use your hand to physically turn it. And this is the layout from the other end. So the beautiful thing about modules is you can configure them in any way necessary to display. Notice how this is in the middle of a wide aisle. Now, we can do this because we don't have, or we didn't have room for a full layout to bring a full oval. So we have this little, we have the ends here to turn the trains around. And that's something you can do and build with modules. These are very flexible designs. You can do a lot of really good modeling with modules. Even low shots look good. Same here. Let me flip through here. So on the subject of legs, because I know this is something that comes up in Q&As a lot. These are PVC legs. This is something that I would like to redesign for these. And, Dave and I have talked about this a couple of times. So I went with the PVC option because on Tony's original layout, that's what he had. There are obviously, again, more approaches to legs, but you can see how they've been reinforced using some metal strap metal and bolts. Here's another view of that. They're all color coded as well, so that one piece of or one cross brace matches one set of legs. And you can see going down. So as you can see in the middle here, these are the Anderson power. These are the Anderson power poles. You can see. Can you guys see my mouse?
Yes.
Yeah.
Okay. These are the Anderson power poles. And that's the standard connector. We have the DCC system hooked up into the middle module to operate the layout. This is going to be DCC. I think Carl earlier said he was a dead railer. I am also a dead railer, so we will be able to operate our equipment on this, no problem. But you do have to have at least DCC in order to operate on the standard. And it's just standard NCE. That's what most of the hobby's using right now. So it'll be just standard NCE. All right. So that is the bit on the local the local group aspect of this. I know I'm kind of a little all over the place on this. Usually I have everything in a script, but I did not bring that with me today. So apologies for being a little messy on the delivery here. But does anybody have any questions about the standard? Anything they'd like me to go over again or touch that I haven't touched yet? By all means, ask your questions. Stop the screen share.
Yes. Okay. Any questions for Nick or for Skylar? This is particularly for younger, newer modelers, going to be a way to recruit folks that we have not necessarily been able to reach as easily. And these are people who are moving around, living in an apartment, still working on a budget, hopefully not still living in their parents' basement. But they are the future of the hobby. If nothing more, we need to recruit them so they can buy our stuff when we retire. So I thank Nick and Skylar for bringing this to our attention. And I've got just a couple of things by way of announcements. First of all, go to O-Scale Central and go to the coming events and look at the different shows that are going to be taking place. The next big one is on November 1 and 2 in Cleveland, which is not only going to have a one-day show, but a second day of modular activity. And I think Skylar is hoping that that's going to become more expanded every year and include an active O-Scale 2-rail modular community. Just a reminder that the next O-Scale Central online program will be on Sunday, November 16 at 4 p.m. Eastern. We're going to have a good lineup. We're putting it together now, not quite done, but pencil the date in on your calendars and watch for the announcements. We're going to be looking for suggestions for program topics. Reach out to oscalecentral.com. And we're also always looking for on-air talent. So if you would like to help in the production and presentations of this show, please let me know. You can do it through the Contact Us feature at oscalecentral.com. We can make you a true star. So, you know, if you think you look good on television, we can start you here. All right. Now we have finished the formal part of the program, and that purpose at least will we will stop, but it has been our practice to continue informally with what we call good and welfare, with announcements, questions, plugs about things O-scale. I wanted to do a shout out to Kelvin Shearson, whose electrons have traveled the longest to get here. Kelvin is from New Zealand and is pretty regular on the show. I want to say hi to John Wubble, who is the head of All Nation. I think I asked him before if he had anything new that he wanted to announce, and he said no. But if you've got anything you want to share with us, we're happy to share that. I've got a model that I alluded to before. Behind me, over my left shoulder, is a model of the cementipede, which was a John Armstrong proto-freelance design for a 200-ton articulated covered hopper. I am sold out of those through my company Wit and Wisdom Models, but I'm expecting a small shipment that should be there by the time of the Cleveland show. So if you're interested in one, let me know. I'll set it aside for you. And for that, you can contact me by email at nkpos2r@gmail.com, NKP for nickel plate. Is there any other announcement that anybody needs to make? Any things happening in the scale? Eric Peterson, I see your hand up.
Yeah, I'd like to remind people of a couple things coming up a little farther out. First of all, March in Chicago is our biggest O-scale event. So be thinking about if you want to enter, build a model for the contest or the display. It's a great place to do that, and we welcome a lot of models there. The other is keep in mind Chattanooga, July, NMRA National Convention, the same thing. We had a lot of O-scale models placed very well this past year in Novi. And also, if you have any information about O-scale layouts in the area that could possibly be open for layout tours, please let me know. And so those are a couple things.
Thank you, Eric. Anybody else? We'll leave the line open for a little while if people want to do crosstalk or ask questions with problems, issues they're having. I note that there are several exchanges in the chat room. If you have not looked at them up until now, before you sign off, you might want to do that. And otherwise, I want to thank our presenters today, Daniel Rabel and Nick Bulgarino, for some interesting, useful presentations on their respective topics. And I thank you all for participating in the show. So we'll leave it open if anybody's got any informal questions or comments, but we are done for the day, and I appreciate your attention. Thank you.
David, since I was late, I do have one question. How soon will this be out on the website so I can catch the first hour? Because yeah, the last hour was great.
Well, we hope we have got both our technical and our staffing problems under control. And the guy who is next to you on my screen, Nick Bulgarino, has taken responsibility for uploading and doing at least a rough edit on the programs and getting them up. But it's Carl, we got him right here. We can ask, how soon do you expect to have this program on, Nick?
Probably in a week. I'm not going to be able to get to David, so I have to actually go to him to get it off of his account. So it depends on my schedule and being able to get there, but probably about a week it'll be up, along with the other 2 that have happened since the upload stopped, since we had the backlog.
Yeah.
But if there's anybody on the call who would like to help with the technical side of operating O-Scale Central, please reach out. We could always use extra help.
Right. Okay. Hearing nothing, I want to thank everybody for your attention. And as I said, I want to thank the presenters in particular for the work that they've done. A lot of work goes into these programs, and I think that's reflected in the quality of the presentations. So thank you all. I hope we see you next month. In the meantime, happy O-Scale 2 rail model railroading. Take care. Eric, you look like you're in a hotel room. You're muted, but you can, there you go.
Yep. I'm up in the Michigan Copper Country, up in the Keweenaw Peninsula, sticking out into Lake Superior. And
How much snow are they?
cool. We haven't seen any snow, and the leaves are past their peak, but we were surprised that we saw some pretty good color, especially coming up in middle of Wisconsin. But I think some strong winds have blown down a lot of the colored leaves as we got further north. But there's some really bright yellows out there yet. So really good.
Carl, aren't you in Minnesota up in that general neck of the woods?
Well, if you're referring to me, I'm in Idaho.
Yeah. Idaho, okay.
And we are getting snow in our mountains and the leaves are changing color. So yeah, winter's coming and I'm not done yet.
Got it.
Still,
Pat Rivard, thank you for joining us. If you are not familiar with Nutrax modeling, it is a good all-scale presentation, and they have topics and guests and segments and so on, and it is worth tuning in.
Thank you.
Anything else? All right. Thanks a lot, guys. I'm going to end the meeting for all, and thank you for participating. Take care. Bye-bye.
Take care.